Today's video tutorial will focus on how to use the features of the application Data Logger Pro 3.3 to conduct video physics analysis. We're going to use actual footage of a projectile launched by a trebuchet. This activity was part of an extended experimental investigation conducted by students at the fictitious Sunshine High School. Now, I believe that Data Logger Pro is an awesome tool for conducting investigations into the equations of motion and so much more. The first step, having built your trebuchet, is to film the successful launch of a projectile of known mass. This footage can be taken using a standard camera, digital camera, in movie mode. Now, it's important to try and keep the camera as still as possible, so I recommend using a tripod. When filming, ensure an object or measurement of known distance in meters is appropriately positioned in the shot. This will be important later when analysing the footage in Data Logger Pro. The movie file needs to be in the format of .mov, .avi or .mpeg or mp for analysis in Data Logger Pro. Once you have successfully obtained your footage, it is time to go to Data Logger Pro for analysis. When you first open the application, you will be there at an untitled workspace, as we have here. The first step is to insert the movie file. You do this by clicking Insert, then out of the list of options, fourth one down, select Movie. Highlight the movie that you're after and click Open. When you first insert the movie, you may find that there is a need for a minor adjustment so that the whole footage can be readily seen in the workspace. Do this by moving your mouse over one corner of the video image and dragging it slightly. It should adjust automatically. So here I'll move my cursor up to the top left corner. You can see it up there. I'll just drag down a little bit, and it's basically helped. It's improved the image of the display of the footage greatly. What I can also do is actually move my cursor over the edge of the video footage image and left click, hold the mouse button down and actually drag it over a little bit more to the left, which is even better still. That can be handy later on when you're moving between different tiles and moving things around. I recommend that you first play through the video to decide upon some key points of reference. You will need to mark your known distance on the footage, and you'll also need to mark the position of the X and Y axis. You can use the controls at the bottom left-hand corner of the movie to play, rewind, stop, and step through frames like a normal video player. So you can play through the video here, just click play, and it'll run through at normal speed. And there's the trebuchet, and there's the projectile if you look carefully. Actually, you can click rewind here and go back to the start. You can also use the slider here to step forward and look at individual frames. And when you're doing that, you can also use the double left and double right arrows to step forward and backward through individual frames as well, which can be very handy. Actually, later on, we want this point at which the ball, the projectile, is released from the sling. So I'll step forward to there now. Now, that's the point there. Now, on the right-hand side here, bottom right-hand corner, you can see this little button down the bottom, Enable, Disable, Video Analysis button as well. Now, this button toggles the Video Analysis toolbar open and closed, and that comes up on the side of the movie here. Now, these buttons are very important for you to get to know. Having a quick run through these buttons we got down the side. The top one, the pointer, allows you to select an individual data point. We haven't added any yet, but we will, and you can select individual data points. That can be useful if you need to delete a data point or something like that. Second one down is the red dot with the crosshair. That's used for adding a data point on the footage. We will use that shortly. Third one down, very important button, Set Origin. Allows you to position your X and Y axes. They can be moved at a later stage too if you wanted to do various different sorts of analysis. The Set Scale button, again a critical button for setting up your analysis. It is used to measure out your known reference distance. That helps scale the footage in both the X and the Y directions. Set Active Points. Okay, this allows for additional X and Y columns for analysis of two other sets of data points. A little bit beyond where we'll go today, but you can read up to that in the help menu, or maybe we'll do that in a future video. This one here, which is already toggled on, is the toggle trails. It shows you the path of data points that you've already added. That's very useful to keep a track of what you've marked and the motion of your projectile, the path of your projectile, or what it is that you're analysing. Next one down, these last two are not as important as some of the others, but they're handy to know. Show Origin just allows you to keep on the image the position of the X and Y axis on the screen, and the last button also shows your scaling distance and keeps that on the screen. That's the one that you measured of a known distance for scaling the X and Y distances. Alright, now the first step is to set the position of the X and Y axis. You do this using the set origin button. Now, being familiar with this video, and as you saw before, I actually step forward frame by frame to the point at which the projectile is launched from the sling. I'm going to use that as a point of reference. So I'm going to actually use the ground as the 0 on the y-axis, and the point at which the projectile is launched as the 0 on the x-axis. So I do that now. I grab my set origin, left click, actually it positions it. I can pick it up again, like I said, by left clicking, holding my mouse button down. That's aligned with the ground for the X, the Y, the X-axis on the ground, the Y-axis through the projectile as it's just been launched, and there I've set the position of my X and Y axis. The next step now is to mark this known distance. In this case, we'll use a known distance on the trebuchet of 1 meter. You will only need to mark one known distance in the X or Y direction to scale the entire footage. It is important that your known distance is also appropriately positioned relative to the object being analysed to avoid any parallax error. So here is my set scale button. I grab that. This is a left click and drag your mouse button. So I drag up. Now I know that that distance there represents 1 meter on the trebuchet. I left click, let it go, enter the distance in units that correspond with the distance in the movie. So we know that this is 1, units is meter, so that's fine, and I click OK. You might have something that's 5 meters long or 8 meters long, depending on what you're analysing. So once you've set up your axis and you've marked your known distance for scaling, it is now time to add some data points. The projectile in this instance is a golf ball. Okay, now you position your add data point crosshair directly over the center of mass of the object, and that's easy here for a golf ball. It's very small, so it fits right there, and left click to mark your first data point. Now what automatically happens is the program will then move forward 1 frame at a time, and that allows you to continue to mark data points until you've marked out the entire flight of the projectile in this case. So there's a second, there's a third. It gets a little tedious, but it's obviously well worth it once you've done it, because you can keep it for really terrific analysis. And you continue on for the entire flight. Okay, and as you can see there, if I use the toggle trail button, if I turn that off, the trail disappears. I prefer to leave it on so I can see the path of where the projectile motion. All right. Now, once you've entered all the data points, it's then time to begin the graphical analysis. So to save time, what we'll do now is move on to a previous version that I've actually already saved. So you can save this work. So I'll click on Open, and there I won't save any changes to this one. Okay, and here is the video footage that I've dragged, that I've completed. There's the full marked data points of the full projectile's flight. And you can see that there, it's pretty easy. There are 3 main active tiles in our current workspace now. Firstly, there's the video footage, which we marked all the data points, the X and Y axis positions, and measured the known distance. Secondly, there is a spreadsheet here, and all of these tiles actually you can drag and expand and change the size here. That gives the time, the X and Y positions, and the X and Y velocities. These are automatically calculated in the spreadsheet, populated with this data as you mark your data points on the video footage. Now thirdly, there are the graphs as well. Now by default, the graph will give you the X and Y displacements as a function of time. Now as you can see on the Y displacement graph, the starting point is the launch height at the release from the trebuchet sling. This endpoint is just above the ground. The endpoint is just above the ground where our footage leaves the screen. It would have been better to have seen the impact, but that's just the way it worked out with the footage. Now, by right-clicking on the graph and selecting Graph Options, we can also add plots of the X and Y velocities as a function of time as well. For this example, what I'm going to do is add the Y velocity in meters per second as a function of time, and add that to the graph there as well. Now the program, now as you can see, the x displacement versus time graph and the y velocity versus time graphs are both linear. We can actually get Datalogger Pro to analyze the linear equations for these graphs by clicking on Analyze up the top here, Analyze, and selecting Linear Fit. Now here we can basically select which ones we want to do the linear analysis for. So we want to do it for the x displacement versus time and the y velocity versus time. So leave those two highlighted and click OK. Now the program now displays the equations for each line, including the gradients, y-intercept, and the correlation. And as you can see, both are very highly correlated. As we can see, the y velocity versus time graph, whose gradient represents acceleration, delta v over delta t, shows a gradient of 9.82 meters per second squared, which is as expected because the acceleration in the y direction is entirely due to gravity. The gradient of the x displacement versus time graph gives us the velocity in the x direction, which is negative in this case, negative gradient, because the object is moving from right to left. And of course is constant, as we would expect, for the horizontal velocity in projectile motion when you ignore the effect of air resistance. And air resistance with this golf ball is very low. Now to conclude this tutorial, we'll look at one last set of calculations that is made very easy through the analysis of motion in Datalogger Pro 3.3. Returning to the spreadsheet data, we can see here the initial x component of velocity was 9.85, rounding, 9.85 meters per second, and the y component of velocity was 8.73 meters per second. We can use basic vector addition and trigonometry to determine the magnitude and direction of the launch velocity. The launch velocity and angle can be found by analysis of the tangential velocity vector at the moment of release from the sling. Using Pythagoras theorem, we can calculate the magnitude using the square root of 9.85 squared, the x velocity, plus 8.73 squared, the y velocity. And that calculates out to be 13.16 meters per second. So that's our launch velocity. We can also determine the launch angle, by finding the tan of the x and y component velocity vectors as well. So in this case, tan theta, opposite over hypotenuse, will be the y velocity over x velocity. So tan theta equals 8.73 divided by 9.85, which calculates out to be an angle of theta equals 41.7 degrees, which is actually a pretty good demonstration considering the perfect angle for launch would be 45 degrees. We're only 3.3 degrees off the perfect launch there. But again, both of those calculations are made really easy with the use of Datalogger Pro. You can analyze range and different things as well, which we're not going to do today. So there's so much more I could show you, but I'll save that for another video. I hope you've enjoyed this presentation and now feel much more confident with how to get started with conducting video analysis of projectile motion using Datalogger Pro 3.3. Thanks for listening.